Welcome back, guys. It's time for the chemistry class. And this afternoon, we'll be treating electrolysis. Electrolysis. Electrolysis is one of the topics in chemistry as displayed on your screen. And electrolysis is a chemical decomposition of any compound, provided an electric current passes through it. It is decomposed by the reason of the passage of an electric current. More so, we have some terms that are used in electrolysis. Some terms that are used in electrolysis. We have the electrolyte. The electrolytes are the conductors. They conduct electricity in and out of electrolysis. They are majorly called conductors. We also have the electrodes. The electrodes are of two types. They allow the passage of electric current in and out of the electrolyte. They allow the in and out passage of electric current out of electrolyte. And we have two major ones of electrodes. We have the anodes and we have the cathodes. The anodes are the positive electrodes that allows electric current to pass through them. And also we have the cathode. The cathode is the negative electrode which allows electric current to leave the electrolyte. Electrolysis was not just gathered somewhere, though it is one of the topics in chemistry, but it was actually postulated by someone, and that person's name is Michael Faraday. In 1833, that leads us to, as it is displayed on your screen, that leads us to the laws of electrolysis. Having understood the fact that electrolysis involves the chemical decomposition of compounds or elements either in their solution form or either in the molten form, it involves the chemical decomposition by the passage of electric current. Two laws were actually postulated. And that is, the first law of electrolysis states that the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity that passes through it. And automatically, that gives us M directly proportional to Q. Mathematically, our Q is the same thing as current that is measured in amperes times time, and we have IT. Q is IT. Therefore, M is equal to ZIT or EIT, where E is a constant of proportionality. That is all about the first law. Talking about the second law, as displayed on the screen, it talks about when the same amount of electricity is passed through different substances, the charge on the ion is inversely proportional to their number of moles. That concludes the second law of electrolysis. Let us move to the questions on electrolysis, some of the miscellaneous questions that comes out in electrolysis. Number one, we have a current of 4.5 amperes is passed through a solution of gold salt for 1 hour 45 minutes. Calculate that's A, mass of the gold deposited. Mass of the gold deposited. Now, when we come to the fact of electrolysis, it involves oxidation and reduction reaction. I believe we know that. So when it is passed through the gold salt solution, the first thing is to oxidize your salt, which is the gold salt. So we have the AU. By the virtue of the charge on each element determines how much electron will be needed to oxidize them. And because we have just a charge here, therefore we have just one electron will give us oxidized gold salt. This E signifies the amount of electricity. We can also call it 1 Faraday to give us this gold salt. And 1 Faraday is 96,500 coulombs of electricity. Therefore, we have 96,500 coulombs will give us, then you find the molar mass of your gold. The molar mass of your gold as given in that question is 197. And we are asked to determine the mass that will be deposited by 4.5 amperes and 1 hour 45 minutes. Now, we calculate our quantity of electricity, which is IT. Therefore, we have 4.5 times 1 hour 45 minutes. The standard unit of time is always in seconds, and that leads us to converting the hour 45 minutes to seconds. How do we go about that? This gives us 4.5. If I'm to convert 1 hour to minutes, I have 60 minutes. I have 60 minutes plus 45 minutes. This is still in minutes. So I therefore change again to seconds. If I'm changing to seconds, I have to multiply this by 60. Therefore, I have 105 times 60. Therefore, when you multiply everything, 4.5 times 105 times 60 should give you 28,350 coulombs. That is still not the end of the question. The question says, calculate the mass of the gold deposited. So, if 96,500 coulombs can give us 497 grams of gold, how much mass would 28,350 coulombs give unto us? That is actually the mass we are asked to calculate. And therefore, when we cross multiply, we have 28,350 times 197 over 96,500 coulombs. The coulombs will trash out the coulombs. This cancels out this. Therefore, our X should give us 57.88 grams. 57.88 grams. Let's move to the next question. The next question says number of mole. Number of mole of gold deposited. Therefore, in chemistry we have number of mole to be reacting mass over molar mass. So, we have our reacting mass, the mass we got by the virtue of 28,350 coulombs to be 57.8 grams over the molar mass of gold. That's 197 grams per mole. Therefore, the number of mole will be 0.30 mole. Are we getting it clear? So let's move to the third question under number 1. The third question asks us to find, that is, if the same current is used, find the time taken for 5.5 grams of gold to be deposited. Let's not forget that the same amount of current we use is 4.5 amperes. So if 28,350 coulombs will give us 57.8 grams, then what will be the quantity of electricity that will give unto us 5.5 grams? Making Q the subject of formula, we have 28350 times 5.5 grams over 57.8 grams. And by the time we're done dividing, our Q becomes 2693.9 coulombs. I believe we're getting some insight about this great topic. Now, we've gotten the quantity of electricity that is needed. The next thing to do is to look out for the time taken for 5.5 grams of gold salt to be deposited in the electrolysis process. Let's not forget that our Q remains IT. Therefore, we have 2693.9 coulombs to give us 4.5 times T. Now, to make T the subject of the formula, we have 2693.9 all over 4.5. This therefore gives us 598.7 seconds. You might actually want to convert the seconds into minutes. Why? Because the seconds is a very large number. But until we're very much asked to do it, we should not convert. So our answer becomes 598.7 seconds. We have another question there. That's number 2. It says, calculate the current that must be passed into a solution of aluminium salt for 1 hour 30 minutes in order to deposit 1.5 grams of aluminium. So the question here is asking us to look out for the current for aluminium. Now, you can still convert this. When you convert this into seconds, you should have 60 plus 30 will give you 90 minutes. 90 minutes times 60 to give you the seconds will give you 5,500 seconds. Therefore, I oxidize my aluminium again. My aluminium carries 3+ charge. That's the same amount of Faradays that will be needed to oxidize it. Yeah. So we have 3 Faradays to give us the normal volume, the normal molar mass of aluminium is 27 grams per mole. So how much, if 3 Faradays could give 27 grams of aluminium, how much electricity will give 1.5? By the time we cross multiply, Q becomes 3 times 96500 coulombs times 1.5 all over 27. Therefore, we have 16,083 0.33 coulombs. But that's not the final. The question still insists that we look out for the current. Our Q is still IT. Therefore, we have 16 Therefore, if we had to divide this equation, we have to make I the subject of the formula. We have 16 all over 5 400. Then if you are to use your calculator, your answer should be 2.98 amperes. 2.98 amperes. Then the third question, if the same current is passed through solutions of silver triazonitrate 5 and copper tetrioxosulfate, copper 2 tetrioxosulfate 6, how much silver will be liberated in the same time as 1.0 gram of copper? Now, we have AgNO3. If I want to dissociate this, I should have Ag plus NO3 minus. Yes. And if I'm to also dissociate my copper 2 tetrioxosulfate 6, I have this. So these are the two major elements we're looking out for. The two major elements that we're looking out for. So because I was given the mass of copper, therefore I will start with copper rather than the silver. Therefore I have Cu2 plus 2E will give me copper. This is the same thing as 2 Faradays, that is 2 times 96,500 coulombs should give me 63.5. That's the molar mass of copper. So if this can give this, then what amount of electricity will give me 1.00 gram of copper? We have to multiply, make you the subject of formula. We have 2 times 96,500 coulombs times 1 all over 63.5. So we have 3,039.33 coulombs of electricity to give us 1.0 gram of copper. Now consider the question that says that what amount will also decompose the silver. So that is what we'll also do now. So checking through Ag plus E to give us Ag, it means 1 Faraday will be needed to oxidize the silver. 1 Faraday to give us 108 gram. So we have 96,500 coulombs will give us 108 gram. So the 3,093.33 coulombs of copper will give us what? Let's call it X. So we have, when you two cross multiply, you make X the subject of formula. then 1 when we divide, we have 3.40 grams. Therefore, the mass of silver deposited is 3.40 grams. 3.40 grams. Checking out question 4. The question says, after passing a current of 4.5 amperes for 25 minutes, 0.221 gram of copper is deposited. Calculate the relative atomic mass of copper. Now looking here, I've calculated everything, and I've also dissociated copper 2 plus 2E will give you ordinary copper. So when we have to multiply this, our X becomes 675 coulombs over 2 times 96,500 coulombs. Therefore, our X, to get the reacting mass, we need the mole and the molar mass itself. So to get this, we have 0.035 moles. And to get the reacting mass, therefore we have 0.035 times 3.5. So that is all about number 4. Looking at the number 5 question, the number 5 question says 44.8 decimeter cube of oxygen was liberated at a cathode during an electrolysis process lasting 30 minutes. Calculate the amount of current passing through the electrolyte during the process, where 1 mole of any gas on the STP is equal to 22.4 decimeter cube. Now, we've been treating anode. And that is why I just had to add this question that talks about the cathode so that we won't find it confusing. To dissociate oxygen, I'll need 4 Faradays to get this O2. And 1 mole of any gas at STP is 22.4 decimeter cube. So I have 4F to give me 22.4 decimeter cube. When you have to multiply this, you still have this. And we're given a considerable volume, which is 44.8 decimeter cube. So if I'm to look out for my quantity here by cross multiplying, I have 4.96500, 4 times 96,500 times 44.8 . Here 1, here 2. So I have 772,000 coulombs. To liberate 44.8 decimeter cube of oxygen, I'll need 772,000 coulombs. Is that all about the question? No. We're asked to find something. We're asked to find the current. So if this is 772,000, and my time, we'll be converting the time to seconds, and then we have 30 times 60 seconds. Yeah, so we have 772,000 coulombs is equal to 1,800 I. 1,800 I. 1,800 I, making I the subject of formula. I have 772,000 over 1,800. Then my I, if I divide it to my calculator, I should have 428 amperes. So this is all for our class today on electrolysis. Do go to share our videos, subscribe, and keep on the notification bell that you might be notified when we have new classes. See you guys. Thank you. Love you.